Hello there, Prof. Aram here, and in this video I'm going to go over the concept of expected return and expected risk. So let's get to this. In the previous videos, when we were looking at the historical data from the capital markets, we were able to calculate the average returns and the standard deviation of the returns fairly easily. But since in finance we are mostly interested in making decisions for the future, we need to be able to calculate the expected rate of return and expected variance or standard deviation for a stock, because you want to be able to know what type of return you should expect from an investment and what kind of risk you should expect from an investment. The first one that we look at is expected returns. The expected returns are based on the probabilities of possible outcomes. So let's say we're assuming that in the future we're going to have a normal economy, boom economy, or a recession, and we assign probabilities to each of them, and then we incorporate the probabilities to the calculation of the expected return. In this context, the expected return means average if process is repeated many times. So the expected return does not even have to be a possible return. It's just what you expect. It can be totally different from what you realize, but before you make a decision, you need to have a good idea of what to expect. So let's consider a game here. For example, if it heads, a student A pays a student B $1. And if tails, a student B gives a student A $1. So if you remember from your stat class, the expected value of this bet is going to be 0.5 plus 0.5 times minus 1. So the expected value of this would be 0. It means that if you repeat this over and over again many times, you should be able to expect to break even doing this bet. However, if the game is only played once, one student will win $1 and the other one will lose $1. So that's how we process the expected return here. We are going to multiply the probability of each state with the expected return in each state and then add them together. Let's look at an example just to make this clearer. Suppose you have predicted the following returns for stocks C and T in 3 possible states of economy. What is going to be your expected return for C and what's the expected return for T? First of all, we need the probability of each state of nature happening. So we have 30% chance of a boom economy, 50% chance of a normal economy, and to find the chance of a recession, you should know that the probabilities always add up to 1. So that means you're going to have a 20% chance of a recession here. So the way we calculate the expected return is by we multiply the probability of each state by the return in each state. So 0.3 times 15, 0.5 times 10, and 0.2 times 2% rate of return in a recession will give you 9.9% expected return for stock C and 17.7% expected return for stock T. In the previous chapter, we defined a risk premium as the difference between the return on a risky asset, like in this case 9.9% for a stock C, minus the risk-free rate of 4.15%. So this 5.75% risk premium for C or 13.55% for T is your reward for bearing a risk, is your reward for investing your money in a risky asset compared to risk-free rate. Now, let's look at the other side of the coin, which is the risk. As you know, we measure risk by variance and standard deviation, mostly by a standard deviation, because variance is in square form, but the standard deviation is in percentages, so it makes sense to focus on standard deviation. So variance and standard deviation measure the volatility of returns using unequal probabilities for the entire range of possibilities. So we find the weighted average of square deviations. So in other words, you find the deviation from expected return, square it, and then multiply that by the probability of each state happening. First step is to calculate the expected return. We've already done this. The expected return for stock C was 9.9% and for T was 17.7%. So what you're doing here, you look at the return in a boom economy, return of C. We're doing it for C. So 15% in return in a boom economy for C minus the expected return 9.9% squared times 30% chance of it happening. Then you do it for normal economy, 10% minus the expected return squared times 50%, and then 2% minus this expected return of 9.9 times 20%. This will give you a variance of 0.002029. And then if you take the square root of this, you will have 4.5% standard deviation for C. And then let's just do one for T. For T, the expected return is 17.7%. So we do variance is 30% chance of a boom economy minus the return of T in a boom, which is 0.25. Sorry, times parentheses 0.25 minus the return. Expected return 17.7 squared plus 0.5. 20% return in a normal economy minus 17.7 squared plus 20% times 1% minus 17.7% squared. So this should give us 0.007441. And if you take the square root of this, you should get 8.63%. So the expected return for C is 9.9 with a lower standard deviation. So lower the risk, lower the return, and then we have higher expected return for T, but also higher risk. So which one of the two stocks should you buy? We can't really say. It depends on your personal preferences and your risk aversion. But we can be reasonably sure that some people prefer C to T and some people will prefer T to C depending on their preferences. So let's work on another example. Here we have 4 states of nature, 25% chance of a boom economy, 50% chance of a normal economy, 15% chance of a slowdown, and 10% chance of a total recession. And we have the corresponding return for each state of economy. So the way we need to do this, if you want to find the standard deviation, you need to find the variance. And to find the variance, you need the expected return. So expected return is your first step. So expected return of this stock is going to be the probability of a boom times the return of the boom plus probability of a normal economy times 8% plus slowdown, 15% chance of a slowdown times 4% plus 10% chance of a recession times a loss of 3%. So the expected return in this case is 8.05%. Now that we have the expected return, we can calculate the variance. So the variance is probability of a boom times return in the boom, 15%, minus the expected return squared, plus probability of a normal economy, which is 50, times return in a normal economy, which is 8%, minus this expected return squared, plus 15% times 4 minus 0.805 squared. And finally, the recession, 10% chance of a recession, negative 3% minus 805 squared. So if we do the calculation here, you should be getting 0.0026. So just keep in mind that instead of decimals inside the parentheses for returns, you can use whole numbers too. It's just a personal preference. And if we take the square root of this, we get the standard deviation of 517. Okay. I hope you find this video useful, and thanks for watching.